G'day, Tony Burke, Environment Minister, and as part of my job I'm in charge of the Antarctic Division and the work and the research that Australia does there. I'm here today with someone who's involved in a whole lot of that work, Tas Van Ommen. Tas, do you want to explain the block of ice that you're holding?
Sure do, Tony. This is a piece of ice core about 2,000 years old from Antarctica, and like all the ice cores that we drill, it tells us a great deal about past climate. It traps bubbles of past atmosphere, which we can tell past CO2 levels, and it actually records information about temperature and about how the atmospheric circulation's changed with dust and other things that get carried to the ice. So when we put all that together, we can learn a lot about what's driving climate change and where we might go in the future.
Okay, so if we start from first principles, how do you know this is 2,000 years old?
We know it's 2,000 years old because we've actually measured all the chemicals in the ice all the way down to this level, and we can actually see each annual cycle and count them off like the rings of a tree. Okay. And so that's how we date the ice.
Okay, and so we've got water and bubbles.
Yes.
What do the bubbles tell you? What does the water tell you?
The bubbles are actually trapped air that was caught between snowflakes when it originally fell 2,000 years ago. And that air gets pinched off as the snow gets compressed, and it's just like a time capsule of past atmosphere. So we can crack those time capsules open. In fact, we do that work with the CSIRO, and measure the composition of the atmosphere 2,000 years ago.
Okay, so, and the bits of water, what do they tell you?
The water actually carries with it some pollutants, trace chemistry, things that get blown in from sea salts from the ocean, but it also contains a mix of hydrogen and oxygen isotopes that actually vary with temperature. And so we can look at that and actually get a thermometer, if you like, of past temperature changes.
Okay, so the depth tells you the year.
Yep.
The bubbles tell you the carbon levels.
Yes.
And the water tells you the temperature.
That's right.
And from that you put the story together.
Yes. And we can actually see over, in the long ice cores, 800,000 years of how temperature and CO2 just dance together through that entire period. Very tightly coupled. But we can also tell that the CO2 levels now are way outside the bounds of anything we've seen in the last 800,000 years.
Okay, so when people some people will say that this sort of bouncing around of CO2 levels and temperature has always happened. There's always been some bounce, is that a bit true?
Yep, there always has, but in fact the CO2 levels have always been much lower than we see presently. So in fact the natural range is about 180 to 280 parts per million. We're now at 390. So we've added as much as it takes the Earth to get out of an ice age. We've added that much CO2 again.
And at what point do the ice cores tell you that spike started to hit?
You can see it rising just at the beginning of industrialisation. You can see about late 1800s that the CO2 levels start to track up.
So the dating's that sharp?
Yes, yep. You can see really quite clearly that from about late 1800s it starts to leave what was the natural background level. And then all through this century it just rises inexorably.
Not a happy story, but if that's the science and the information, it's important work that you're doing.
Thank you.
Thanks very much, Tas.
Pleasure.